Limited. So today, seeing as though I just finished my first year and as being an engineering student, I thought I'd talk to you guys about how to decide a major, because most of you are going to have to either decide that this summer or in the upcoming summers. And even if you're going to be like a sophomore next year, I think it's really valuable to just start thinking about it. I know it can seem really stressful, but years down the line, when you're finally trying to get into college and stuff, it really pays off to kind of have done your due diligence and know what you want to do. So I guess like as a little background.
Can I also comment in on that?
Yeah.
A lot of engineering majors say that they're 4 years, but if you don't start on the track from day one, you will not get out in 4 years. But 5 years for an engineering science degree is totally normal nowadays.
Yeah. Oh, and quick disclaimer, if you guys have any questions or comments, please interject at any time. So I go to the University of Southern California. When I applied to colleges, it was like 2 summers ago, so when I was going into my senior year, I thought I wanted to go into biomedical engineering, so for every college that I applied to, I said, oh, I'll be like a biomedical engineer. And then I figured out I was going to USC, and last summer, I was just researching stuff, and I was like, oh my god, like I do not want to be a biomedical engineer, like this is awful, I don't know why I chose to do this. And lucky for me, USC is really lenient about changing your major within the engineering program, and so I got to change to mechanical engineering. But I think it's really one of the big things about choosing an engineering major is kind of realizing what you're going to do like down the line. Like it's really stressful to think about college, and so on top of that, thinking about career would like give me a heart attack whenever I started thinking about it. But I realized that as a biomedical engineer, and if you choose to go into any super specialized engineering majors, like petroleum engineering or nuclear engineering or biomedical engineering, if you end up getting out of college and realizing that you want to, I don't know, like work at Apple and help design iPhones, it's going to be really hard because a lot of the companies who hire you will be like, well, we could hire you who has like some biology knowledge and some mechanical engineering knowledge and some electrical engineering knowledge, or for design purposes we could just hire like a mechanical engineer who's been doing this for like 4 years instead of like this weird mishmash. And so I know a lot of people who are going into biomedical engineering who just know that they want to work on medical devices for like the rest of their lives, whereas I was like, I don't really know if I want to pigeonhole myself. And so I think that's one of the really important things that you have to think about is you can think about whatever it is that you specifically like doing, and then you have to realize like, will I really, if I do choose to go into something super specific, will I want to stay in something super specific for the rest of my life? I personally am a really big proponent of going into one of the like core engineering specialties, so like electrical, computer science or computer engineering, and mechanical, because I think if you go into one of those, the opportunities when you come out of school are absolutely limitless. And if you think that you like a weird mishmash of those, you can always apply to programs like Berkeley's EECS program, which is like electrical engineering and computer science, which really pays off.
And a lot of programs will go into the electrical engineering program, and that's your major, and then you have a concentration within that. And usually the concentrations you decide later down the line.
Exactly.
So that's usually for big schools though.
Yeah, and that's another thing. So I bet a lot of you know what you want to major in, especially if you're at a camp like this. It's probably going to be engineering. It's probably, you know, if you're like mainly coding stuff, you'll probably want to go into like computer engineering or computer science. And so when you do that, that's really nice. Like you really set yourself out on a good track. But what happens to a lot of kids is they end up applying to big school, like big UCs, and they realize that the major that they originally applied for, like they don't want to do. Like, oh my god, I don't want to be an electrical engineer. Like I want to be a mechie. And what ends up happening at like some schools is it's really hard to change majors because we all know that UCs are like absolutely massive, and it's like really hard to even graduate on time at those, even though they're really great. And so a big thing that I've heard a lot of my friends say is that they wish they would have known like how easy or hard it is to change majors before they had decided to commit to a specific college. So if you think that you know what you want to do, that's great. You can literally apply to any college because no college is going to like kick you out of your major once you're in it. But if you're someone who you know you want to go into engineering but you're undecided, It's a lot nicer to go to a school where you know you have the leniency to change majors instead of having to jump through a ton of like bureaucratic hurdles once you get to college just because you decided you want to work with circuits instead of like steel beams and things like that. And so that's like kind of a glimpse into like actually once you get to college, but even before going to college, there's a lot of really cool quizzes online. I actually took one yesterday that can help you decide because once again, like it's really easy to say, oh, I like engineering, but it gets really difficult when you have to choose because all the branches of engineering are quite different. And so there are like really good quizzes online that can kind of test whether you like to do tactile things with stuff you can see, or if you're more into like theoretical things and things that you can't see. So like for example, as a mechie, I like doing stuff with things that I can see. Like I like building stuff I can see. And so I probably wouldn't ever go into electrical engineering because obviously you can't see much of what you're doing when you do that, and that stresses me out to no end, and I don't think I would like to do that.
And me, on the other hand, I don't like to see what I'm trying to build. Kinematics, which is like, oh hey, look, this thing dropped, let's calculate all the equations and stuff for that. Of course, there's more to it, and it's a lot more exciting than that. I specifically don't like it. When there's taking something visual and then trying to translate that to math, my head gets all mixed up and I'm bad at it. But electricity and magnetism in physics, where I can actually see what's going on, I loved it. It was great. I just treated it like math. I'm weird, as you guys probably figured that out. So it works for me. It doesn't work for everybody else.
Exactly.
And one thing I've learned here is that my education at my school has been very focused. I'm realizing how focused it's been in that electrical engineering, as far as the way I'm learning it, is like we learn how to build a whole different, we can build whatever we want, but the skills we're learning are very narrow as far as like we learn how to design circuits and write firmware. If I try and build a bridge, don't drive on it.
Exactly, so that's a big thing. And also another big thing is that going, like you all know, going into college or even high school, like the reason why you're there is to learn things. And so a lot of times people will really like to tinker, really like to build stuff and go in and be like, oh, right off the bat as a mechie, like I'm just gonna be building stuff left and right. When in actuality you have to slog through math classes and physics classes and all these classes where I don't get to build anything. I just sit in front of a textbook and get lectured at and have to figure out all these equations before like my senior year when I'll have my capstone project and then I can start building really cool things. And so a lot of times what you have to realize is that you also have to be in love with like the theory of whatever you want to be learning, because right off the bat a lot of times like you'll get a few hands-on things, but it won't be like, oh my god, I'm gonna go and build a bridge, like catch me outside. It's not.
So I know my engineering friends had things like SAE. Does your school have stuff like that? Do you want to talk about kind of the way that you can actually be building things the whole time?
Exactly. So yeah, SAE, a lot of...
Can you tell them what SAE is?
Yeah, so SAE is where you build like a race car pretty much, and there's a huge competition where you get to race that car against the other schools. That it's actually a national competition. There's also things like, at least at USC, there's a jet propulsion lab where they build like actual like rocket ships, well not rocket ships, but rockets that go like pretty high up. A lot of times they'll have things like chem-e cars. If you're into chemical engineering, you can like, I have no idea, I don't even know anything about chemical engineering. And so those are really great ways when you're like stuck in your dorm doing homework and you're like, I want to go do something tactile. Those are really great ways to begin to apply the knowledge that you're learning before like your actual curriculum really ever gives you a chance to do that. And that comes around to a great thing about engineering, which is networking. A lot of times it's really great to meet upperclassmen in college who have been through the exact same classes that you're doing, because they know all the tips and tricks that you don't know. Like, for example, one of the physics professors at our schools, he doesn't tell anyone this, but if you get an A on his final, you get an A in the class, regardless of how you've done. Like, you could literally have a D in that class, but if you get an A on his final, you will finish with an A in the class. And so and he doesn't tell anyone that. However, all the students who had his class know that, and they will be more than happy to tell you. And so a lot of times in a really big school where you don't know where to find other like-minded individuals, joining something like build teams, like the SAE team, the Jet Propulsion team, are really great ways to make more friends, B, find like-minded engineers who enjoy the same things as you, and to get an upper hand on kind of just navigating a curriculum that otherwise can be very tricky.
And to add on to that with those clubs, if you show up to one of them freshman year and you sit in the first meeting and your head starts spinning because everything is just going way over it, like my first experience sitting with the Marine Technology Club, that's totally fine, and you should stick with it because you will learn and they'll find stuff that you can do, and as you're there you will learn and you will be able to do more as a result of staying in that club. I got kind of scared off from the Marine Technology Club, where we pretty much get to build like a remote controlled submarine that has to do different tasks, and then you go and compete. And I really regret that because I would have learned a ton. But I was just like, oh my god, this is so complicated. I got out of there. And then I realized in hindsight that if I had stuck with it, it would have started making sense the more I stayed and the more I tried to do.
I have a question for the room. I'm curious who can tell me the differences between the different types of engineering. So can you define like mechanical engineering versus electrical engineering, or even like electrical engineering versus computer engineering versus computer science? Anyone have input?
Yeah, at least what do you expect from these branches? Has anyone decided what field they want to do their engineering in, or if they want to do engineering in the first place?
Yeah. If you want to be like an English major there or something, I can't help you. I don't know.
I'm going into computer science,
Okay.
What is computer
Yeah.
science?
Why?
working with computers.
So what's like the difference between computer science and computer engineering?
Computer engineering, if I recall, is more the hardware of computers, where computer science is software,
And what's electrical engineering?
working with electricity.
But don't you use electricity for all of them?
Specifically, what kind of
Electrical engineering, like circuits.
Yeah. So
Yes.
circuits.
Yeah. Electrical circuits.
Yeah. Well,
Computer engineering is more to do with writing firmware, micro level designing of computers, and things like virtual memory, operating systems, stuff like that. When you talk about computer science, it'll cover more high level things like machine learning, artificial intelligence, and algorithm based stuff that you do at the high level. And there are algorithms at the low level as well, but yeah, you can.
Just for clarification, Chaitanya used some good words there, high level and low level.
Uh-huh.
Doesn't necessarily mean like more difficult or more complicated.
Oh yeah.
Higher level means something that's like closer to the user. So like an application is very high level. The language that application is written in is slightly lower level. If you go down further than that, you get like assembly language, and then from there, there's like it gets more into like hardware and stuff like that.
That's,
So like the very lowest level is like transistors and electrons and stuff like that, and the very highest level is like what you're looking at on your screen, and it's kind of a continuum. And I think that's a big part of the difference between like those different fields.
Yeah.
Electrical engineering is very focused on lower level stuff. Computer science is very focused on higher level stuff, and computer engineering is kind of
Somewhere in the middle.
between.
Yeah.
I can tell
Thank you, Ben.
the different programs, and even though electrical engineering at one school could be completely different than electrical engineering at another school. Actually, when applying for this job, I figured out what my school's program is more focused in, and we're more focused in communication theory, so how does data get through the air and through wires and all that stuff, and embedded systems, which so I'm not entirely sure what that word means.
Basically Arduinos
Um,
for all practical purposes.
yeah, it's like the way I think of embedded systems is any type of electronic where it has like pretty much one defined purpose
Yeah,
and it just does
that's
that. Whereas a computer is a computational system and it can do a whole
Multipurpose.
bunch of other stuff. So what we don't, our electrical engineering program is a little bit higher level than other ones. We learn about the basic components, but we really learn them just to get the experience and the knowledge, and then we don't really put that into practice outside of those classes. So we don't learn how, like, as far as looking inside some of the ICs we've been using, we don't really learn what goes on inside of those. We learn more a little bit higher level than that. We learn how to use those ICs in some big electronics. So really my program is like, I'm learning how to build electronics. So it's pretty much everything you guys are all doing right here, but from scratch. But we're not from very scratch because we're not building the ICs. So that's kind of like, even within electrical engineering, there's so many different focuses, and yeah.
Yeah. So that's for electrical engineering. Caitlin, will you talk about mechanical engineering a bit?
Yeah. And Eric
Why you chose it?
obviously helped out.
Yeah. Eric and Caitlin are mechanical engineering experts.
So mechanical engineering, we like build stuff out of material. And it's actually a lot more than that. Like there's, you can work with like thermodynamics, fluid dynamics, and like mechanical engineers really have like a pretty wide breadth that, and you can dive into it. So just because you go into mechanical engineering doesn't mean you'll be like working on designing cars, you know, in a few years. Like a lot of them can work on like HVACs, like working on like cooling systems and things like that. So it's a really wide field, I'd say. What do you have to add?
It's important to note, like, again, back to what do different programs focus on. I had a very broad education with, like, a huge array of topics. As Caitlin was mentioning, like thermofluids, heat transfer, fluids, statics and structures, mechanical systems, and then you can select your path. But I have a buddy at Purdue, and he focused his entire undergraduate degree in HVAC systems. So he's doing like thermofluid cooling. And so it really depends on what program you really want to go into. You know, obviously each field is like super broad, and I have a very broad background because of the experiences I saw it outside of the classroom to educate myself. So I can't harp on those enough as like a very great learning opportunity. The reason why I'm here today to teach you guys is because of the opportunities I sought outside of my degree program. The reason why my electronics knowledge exists is because of stuff I did outside of my degree program. So I would encourage all of you to find something you really are passionate about. So I love moving things. Like I loved building like cranes. I found out in high school through through an engineering competition, I had a great time building a crane. So I got to do like all the woodworking and all the like hardware development for that. And then from there it was like, oh, I like mechanical engineering, and from there I really was interested in like the business administration and management of engineering projects. So you'll find out like what suits your desires and needs as you learn more, but start with something that like you're already interested in.
Yeah, agreed. And this program is really great. Like this program is a really big reason why I got into college, because I was able to show the potential, like the administration on each college board that, look, I know how to build things. I know what I'm getting myself into. I'm ready for this. I'm not, like a lot of kids are like, oh my God, like computer engineering, like I can make a ton of money. I'm just gonna go into that. And they don't realize that it's like really hard, and you can't just like waltz through that degree. And you can't really waltz through any engineering degree, to be frank. But this program and just doing extracurricular engineering things in college is really great, because as you're all learning, you always run into problems. Like there's just problems left, right, forwards, backwards, wherever you go. And a lot of times when you get hired, they want to know that you know how to solve those problems, because it's one thing to sit in front of a textbook and just crunch numbers, and it's a whole nother to be like, okay, I hooked up the circuit exactly how it said and it's not working. Like, why is this? And like, to be frank, a lot of your professors won't teach you how to do that. They'll teach you, you know, Ohm's law, so you can, I don't know, I guess figure out that some current's going through somewhere in these wires, but they won't teach you why it's not working. So that's where all that really hands-on stuff like this really helps you out and puts you like light years ahead of the other kids who just stay in their dorms all day studying and not really ever applying any of the skills that they're learning.
Yeah, so to add on to that, I think to sum it up, engineering is something about solving problems, and think about what problems you see in your daily lives and think about how you can solve them. That builds up stuff, that makes you think, that makes your engineering skills sharper, and then you can actually choose your field. to give an example, we talked about we talked about mechanical, electrical engineering, computer science, computer engineering. I saw a TED talk one day about a chemical engineer from Purdue who is into the profession of designing bowling balls. And there are only 5 people in the world who design bowling balls. And the amount of physics that goes into it, the material sciences, the mechanical engineering also to some extent, is amazing. You should watch that TED talk, and then it's like whichever field you go into, you should enjoy doing that, and you should be solving problems. That's what engineering is about.
Some of you also might be considering studying something more theoretical, like pure mathematics or physics. I was wondering if Chris could talk a little bit about that.
Yeah, so I did a I majored in physics with a minor in computer science, and then I did my master's in physics. And so my school is actually a very small school, and the physics class that I took, all the physicists and the engineers took the same kind of intro level physics class. Generally, I don't know, I think at most schools, like the engineers take like a year-long physics class, kind of their first year. Is that your people's experience as well?
Yeah, I take it second year.
Oh, second year, yeah. So something like that, like you'll be taking, like all engineers, you have to take physics. So you've got to take like pretty much everybody I've ever talked to, it's like a year-long physics course, your first or second year. And so you'll have some exposure to the theory and stuff, and you know, if you really like that, if you know, like the reason that I went with physics is I really enjoyed delving into why things work, like really getting all the way down. So like, you know, when I'm thinking about how like an Arduino works, I really like that I can go and I can think about, okay, you know, what is this chip made out of? You know, it's got like all this silicon stuff, and I can think about the material science of that silicon, and I can go back and I can think about, okay, well, you know, we've got this like doping schemes, and we've got different elements, and I can go back and think about like the atomic physics and the chemistry and like all of that stuff. So like to me, I really like being able to like understand kind of like all the way down to the bottom.
Chris, I'm super glad that's you.
So that's not for everybody, but like if you really like doing that, you know, physics is totally an option, and you can also do engineering and physics. Like I had a friend who did a physics major with I think it was an engineering minor. With a minor, you didn't specialize in like Mechie or EE. And I also had friends who did engineering majors with physics minors. They're like degrees that go really well together. A lot of friends I also know end up doing like a math minor along with engineering. I had one friend who's a crazy person who did a triple math, chemistry, mechanical engineering major.
Sounds like a blast at parties.
Yeah.
You can do all sorts of things.
She was a really cool person, but yeah, she was like, I don't understand how she had that many hours her day. She also did that in 5 years. But yeah, like that's another thing to be thinking about is, you know, just because you are majoring, you know, in one thing doesn't mean you can't have like a minor in something else. I think pretty much all of my friends had, you know, major and a minor. So if there's something else you're interested in, you can totally do that. And also just, you know, because you're doing physics, like we didn't sit there and do calculus all day, every day. Like we actually also build things. Like, you know, you have like, to me, I went into experimental physics, and so you're building equipment and you're figuring out how to do experiments. And we had like labs where we had to sit down and figure out how to get different experimental apparatuses to work, and sometimes you don't have what you need and you got to build your own thing, and sometimes you know, I'd have to go talk to the electrical engineer, the mechanical engineer, and be like, hey, I need this thing, and like they'd help me figure out how to get it put together. So like I really enjoy building stuff, which is also like why I wanted to do this program, but I also really enjoy the understanding, and so kind of having the physics really helped me understand stuff, and then doing more experimental physics means I still get to do hands-on things and do a little more of the engineering side of things, because like I wouldn't have really been happy just doing a pure engineering major, but combining those kind of two disciplines I really enjoy. So there's always that option too for you. And if you first year you're like you find yourself asking why a lot more than your other engineering friends, physics might be for you.
Just to echo a little bit of what Chris said, and one last thing is don't be afraid to challenge yourself. If there are multiple things that you want to study, you want to do engineering, but you also want to look into computer science, major in both. If it's not going well, you can always drop one of them.
Or switch one of them to a minor.
Or switch one of them to a minor. Especially in the beginning, don't be afraid to push yourself, because when you have more work and you have more of a challenge, you'll be very impressed by what you can do. And so I would say never shy away from something that you're interested in just because you're afraid it's going to be too hard or too much work. Just do everything that you want to do and try and get as much out of college as you can because it will go by quickly.
Yep.
So
Right.
if you have any questions, all of us are in
Yeah.
or going into college, so.
Go ahead.
How much interdisciplinary stuff is there in general when you're like learning from the classes?
So like for me as a computer engineer, we have to know like electrical stuff. Like we have to. That's just a part of computer engineering. Is that our software skill is not as good as the CS, but we know more about electrical stuff than the CS people do. So if you take computer engineer, it's like kind of like electrical and then CS stuff. So it's yeah.
There are also some other majors that are more interdisciplinary by nature. So, for example, we talked a lot about mechanical engineering and electrical engineering, which tend to be more of like the pure type engineering majors. But if you study something like environmental engineering or biomedical engineering, they'll be more focused on one like industry, like medicine or like environmental science, stuff like that. But biomedical engineers focus on both mechanical and electrical engineering. Environmental engineers, same kind of thing, and even some like chemical engineering when like solar stuff comes into play.
There's
So
a
if
lot
you're-
of different types of engineering majors.
Yeah.
Like my master's at LSU, Louisiana State University, and they have a huge engineering program. And like I swear, like every semester I just learn about a new engineering major I've never heard of before.
All right, thank you for listening.